Okay, this is the first podcast for Unit 2 where we're going to talk about atomic structure and matter. And what we're going to talk about in this first podcast is about classifying substances and really getting clear about terminology. Okay, so let's go ahead and get started. So in this podcast, we're going to learn the difference between an element and a compound, a homogeneous mixture and a heterogeneous mixture. Okay, so if I look at some ways of classifying. There's lots of different ways, but we're going to take a look at classifying as elements, compounds, or mixtures. So an element is a substance that cannot be decomposed into something simpler because it's made up of the basic building blocks, right? So if you have an element, they're all going to be one type of atom. You will be able to find it on the periodic table. They might be something like lithium or iron that exists just as an element all by itself, a single atom, but it could be something diatomic like hydrogen. Hydrogen exists as H2 with two atoms of hydrogen combined. That's just in its natural state how it combines. And you can even find some strange ones like sulfur, which exists as S8 or 8S atoms chemically combined. Okay, but they're still an atom. They're still an element. As long as they are the same atom, they are an element. Now, when we combine elements, we end up with a compound. So a compound is a substance with two or more different elements that has a constant composition. They're chemically combined. They can be broken down to elements by chemical means. Okay? Okay, so we're going to talk about sodium and chlorine on the next slide, but I want to talk about mixtures. There's not a lot of space down here. So a mixture is two or more pure substances that are combined. And those pure substances, when they are combined, retain their properties. So if I were to make salt water, which would be a mixture of salt and water, it still tastes salty. It still has a watery feel to it. Okay, so that's the nature of mixtures. The mixtures can be separated by physical means. I don't change the composition of the salt compound or the water when I separate them. I still have those compounds. There are two types, homogeneous, which means the same. So visually, I don't see any differences. Or they can be heterogeneous. Heterogeneous means that they are different. So if I look at them, I can see the differences. So if I looked at salt water, for instance, that looks the same. It's going to be homogeneous. If I looked at a mixture of salt and pepper, that would be heterogeneous because I can see the pepper flakes within the salt. There are differences. Okay, so it's interesting that I can take two elements, and let's say I take sodium, and sodium is a metal that if I put it in water will explode. And chlorine is if we had chlorine in the room, it would be a green gas, and we would all die because it's a very toxic chemical. And if we were to combine them chemically, we end up with sodium chloride, which we go ahead and eat. Okay, so the properties of the sodium and the chlorine do not get retained, and I end up with something completely different. Okay, as opposed to a mixture. If I had, let's say, a mixture of salt and sand, if I were to put that in my mouth, and I don't recommend doing that, it would still taste salty, and I'd still have a gritty texture on my teeth. It would be pretty gross, actually. Alright, so here we're going to take a look at three different samples and try to identify which one is which, right? So we want to identify whether we have an element, a compound, or a mixture. Okay, so let's take a look at A. So A, first of all, I want you to try to see if you can do this on your own. Go ahead and hit the pause button and see what you think. Okay. Now in A, this would be a mixture. Now it's a mixture. This guy right here would be an element. This guy right here would be an element. And I know that because they have the same type of atom. This would be a compound because there's two different types of atoms. Okay? But because I have different stuff in there, it is a mixture. So this is a mixture. And I can't really tell whether it's going to be homogeneous or heterogeneous because I'm looking at it at the atoms. Okay? Alright, so describe this. So I have all the same type of atoms, so this is going to be an element. Okay? In here, if I look, I have, again, each of these is made up of the same type of element, so this also will be an element. A lot of people would say it'd be a compound because I got stuff bonded together, but that could also be an element. This is probably a sulfur. Okay? Alright, so here we have a chemical reaction that occurs. So we have stuff here becoming stuff on the right. So in the before picture, we have a mixture of two elements. The pen's not working so well. Let me fix that. A mixture of two elements. Right? The orange is one element, the blue is the other element. In the after picture, I have just a compound, and it's a compound composed of those two elements. So what type of a change occurred? It was a chemical change, and the way I know is the composition changed. These are, because they are together, they are chemically combined. They are always the same composition, right? It's always one blue and one orange. Okay? So I know it's a chemical change. If I had orange and blue separately, it would be a physical change. Alright, so let's take a look at how we classify. At the top we've got all matter, which we can separate into pure substances and mixtures. Pure substances can be further divided into elements and compounds, and mixtures can be homogeneous or heterogeneous. Alright, so let's take a look and identify. Go ahead and try this on your own. So table sugar, sucrose. We know sucrose is because I'm lazy, I'm going to abbreviate. Sucrose is a compound. Right? Same composition, bunch of different stuff chemically combined. Chicken noodle soup, clearly a heterogeneous mixture, lots of stuff in there. Helium, gas, and a balloon. I can find helium on the periodic table, so that is going to be an element. 10-karat gold ring, pure gold. So the fact that pure gold is 28 carats, and this is 10 carats, means that I have a mixture, and I'm assuming that that ring looks uniform, and because it does look uniform, I'm going to call it a homogeneous mixture. Kool-Aid, is a bunch of stuff dissolved in water, so that's going to be, again, a homogeneous mixture. Table salt, it's sodium chloride, it's a compound, so it's a compound. Okay, that's going to do it for us.